So we are going to start our first group of 5-minute talks. My name is Jackie Jensen-Vallon. I'm at Lamar University and have been excited to be involved with this conference for several years now. The 5-minute talks are an opportunity for people to share snippets, little ideas of what they would like to share with the whole group, from people who maybe didn't have a chance to sign up for a longer talk or didn't realize until they got here that they had something they wanted to share. There are still sign-up sheets around, so feel free to put your name on there as the conference continues. Our first three, I'm going to give you warnings so that you guys can get yourselves organized. Our first three 5-minute talks are going to be Annie Selden, and then Diana White, and then Leon Woodson. So if you're in the room, get yourself ready for that. We will ask that our 5-minute talk people come up and use this mic so we don't have to re-mic people. And if you have technology, that's fine, but you have to do it in quickly, please. We have 6 5-minute talks in 30 minutes. 29 minutes because I just talked too long. So, Annie Selden.
Okay, so this is a new journal. It's accepting papers. Its acronym is IJRUM, International Journal of Research in Undergraduate Mathematics Education. Publisher is Springer. I looked, the website is accepting papers, it's all there. This is a research journal, so it doesn't compete with things like Primus or Giblum or anything like that, and I know that there are some math ed researchers or budding math ed researchers out there. And I would like to point out that it's got a very large editorial board. Some of them, well, I know Vilma Mesa is here, but you know some of the other people like Hy Bass and David Brissaud and perhaps Marilyn Carlson and so forth. But it is international, so there are people from all over the world. I scratched in that right now it's going to have 3 issues a year, so 12 to 15 papers. They're going to be double-blind. They're going to be about 3 reviewers, usually called referees by mathematics journals and mathematicians, 2 from the board for consistency, so that's why the board is so big, and 1 outside. Now I'd like to tell you a little bit about the history because a lot of you haven't been hanging around as long as I have. So there was, once upon a time, the Committee for Research in Undergraduate Math Ed, which was a committee of the AMS, the MAA, AMATIC, and NCTM, and they worked for a lot of things, speakers at the joint meetings, things like that. They also got the volumes, Research in Collegiate Math Ed, going with the attempt to prove to the math and other community that there were enough papers out there to start a journal. Well, I wrote an article in UME Trends, which you may not remember because UME Trends was short-lived, but it was out of the calculus reform movement, which you may not know about either because sort of it either got absorbed in things like, you know, the Harvard calculus was about the most reformed book that's left. Anyhow, I wrote that article in 1992 and I said, a journal for research in math ed, an idea whose time has come. Well, it wasn't the time because it's taken from 1992 to now to get this journal, and a lot of different people have been involved in making this happen. So one of the reasons the reason for doing the research is also not just to talk to each other, but also maybe to get it out here. So some of you may want to submit to it, but some of you may want to read what's published there. So I just want to say to look for it or to submit to it. Thank you.
So in 1 second, we'll have Diana White, followed by Leon Woodson, and then V.A. Samaran Nay?
Thank you. So I'm actually giving this talk on behalf of Sibylla Beckman, who's a mathematician and mathematics educator at the University of Georgia who specializes in the elementary preparation of teachers. And she's been giving lots of talks at different conferences and doing a lot of writing about professionalization of the mathematics teaching community. And toward this end, she sent a few slides that she asked me to go over with this particular audience, and we realize we're basically preaching to the choir here, but we also want to invite you to consider joining this mathematics teaching community. And so what we want to do is we want to see ourselves as connected across the entire P20 spectrum of teaching mathematics, that we're not just teaching in whatever particular silo or level we happen to be in the most. And we also want to develop a system where we develop shared repository knowledge with the advent of things like Blackboard, Canvas, various course management systems. A lot of our materials and stuff are now behind, essentially locked to where we don't share them with each other. And basically, we want to develop systematic knowledge with regard to teaching and share knowledge and resources and ideas there in the same capacity that we do with our research. So you walk down the hall, you talk to people about your research, but perhaps not so much your teaching. And so one of the goals of this community is to head toward more a systematic peer discussion, peer evaluation, peer mentorship with regard to teaching. And this community really is already excelling at that, but many of you may be in institutions where they're not as advanced in your own department as this particular group and so on. And what we'd like to do, go on to the next one, is I want to point out that she started this wonderful online discussion forum known as the Mathematics Teaching Community, where you can submit comments, you can submit questions, you can share materials, you can read and respond to things other people are doing and so on, but also it's heading in the direction of advocacy. And for example, she took the lead through this community of writing a letter to Secretary Duncan related to some specific concerns dealing with math education at the national level. And so, respecting the short time here, that's just that there. I won't read it to you, but it's a quote excerpted from the letter to Secretary Duncan. And on that note, I'll end there and say she was extremely generous in throwing my name and email on here. I have no intellectual contribution as of yet to this community whatsoever, so please do contact her. This was entirely her doing with support of some other people, and her email is up there, and if you just Google Sibylla Beckman Mathematics Teaching Community, it should be the first hit that pops up. So thank you.
Hello, I'm Leon Whitson from Morgan State University. I'm going to talk briefly about Spiral program. It's a program that's now at Howard University. For the last 10 years, this program was over 10 years at the University of Maryland, College Park. It moved there. Thank you for the opportunity to finish my 10-minute talk from last year. Okay. Now I'm going to go through this briefly. It's a summer research program. It gives you a look at some of the people. Now, what happened this year, I want to just have basically a story about what happened one of the times. I think it's a nice IBL story, right? I asked the question, in terms of research, we would do presentations for the students and say, hey, what kind of questions we may want to look at. And so I'm in combinatorics. I was looking at questions of counting how many paths you would have under certain conditions. Now, the approach that was done, and the approach that I was familiar with, was setting it up in terms of a power series. We take these numbers, they're going to be the coefficients of the power series, you look at the generating functions, right? 100 years, everybody's known that first line, that the other ones, you can kind of generate those from what you get in the other cases, right? Restrictions can be that you can go up, you can go down, you can have a level step. And so with the students, this was my group. It was a very good group. Just very quickly, just to mention this, it was really, really talented, all four of them. The one in the vest he thought he was the alpha. Right from the beginning, when he walked in the building, he thought he was the alpha. He was wrong. He was really wrong. One of the people that I work with, and the person that got me involved with the group, is Marshall Cohen. Marshall Cohen was Morton Brown's student who was Bing's student. And we've now been working together for 10 years. He works with me with NAM, and I work with him with Spiral. Right. So what happened with this group was, and I want to mention this, okay, I'm skipping through. I have the whole presentation. Obviously, it's not going to make sense for me to think about doing that, but what I like about having it up is going to give me an opportunity to brag. Right. Looking at this, like I said, for 100 years, most of the publications have this thing in terms of a linear. You look at the numbers and you look at the power series that you get along the level steps, along the levels. So I suggested that they kind of play with that, see what they do. I was in a nice situation. We had 6 boards. I had 4 people. But they decided they wanted to do it along the diagonals. So I said, okay, I don't think that's going to work, But go ahead. And then I'm thinking about it. I said, okay, 6-week program. We may lose a week or 2 with them bumping their heads up against this problem that they may not be able to solve. I said, cool. So I let them bump their heads. They surprised me. I even brought an audience for them to fail. And they surprised me. They came up with solutions. Right? I'm running through these because, we obviously can't look at them. But they worked out solutions. They were not able to find functions in what I call a multiplication function. A function that'll take you to the next one by just multiplying this function, then I want to take you to the next one. You could do that. Along the diagonals, it didn't work. And I knew it wouldn't work. But they didn't care. They went through, they found solutions. They set it up in terms of generating functions. Now, the way we worked it was they did conjectures. And they had a conjecture. I said, do you believe it? And I said, okay, keep going. Do you believe it? Keep going. Do you believe it? Keep going. And then at some point, you got to stop and prove everything. So we backtracked, and then they went through proofs. Since I separated them, at times just daily, I had 6 boards, 4 of them. A lot of times they worked alone. They worked in teams of 2, but they virtually never worked in all 4 together. And I didn't always have them work with the same person. They came up with 2 different solutions, separating. Alpha Dog was the one that came up with a different approach because he was certain he could do it, but somebody else had to prove it for him. But that was fine. So they had a different proof to prove the same thing, right? Now, they decided to expand, look at some other examples. They came up with, I asked about a generalization. They came up with a generalization. They went on to prove the generalization. Right. And then they came up with a third proof. This one was not Alpha Dog. Right. Now, the way they wanted to do their presentation, I was in favor of the idea, but I felt that they would have some problems if they did it this way. They wanted to list all their conjectures and then prove everything at the end. And I said, no, people are going to stop you. They're going to interrupt you and say, and so they were forced, unfortunately, I forced them to do it and I didn't want to. They were forced to do the proofs right after the conjectures, which I guess now just theorems, right? Okay. Now again, more generalization, slightly different version of the proof, right? And so normally I would say, okay, can you generalize? That's going to be your future work. And they said, no, we don't have any future work because we already generalized. Yeah, okay. All right. My 5 minutes are up. I've never had that happen before. Okay. Okay. Any questions about that? Because I did run through that. I didn't allow you to see anything in terms of what they did. I just wanted to show off that they did a lot of stuff in 6 weeks.
Okay, so VA is on his way up, and then Brian Katz, and then Corey Clarkson, and that'll be the end of our 5-minute talks for the morning. Not 10-minute talks. That was wrong.
Okay, while they're getting the slides on, my name, no one pronounces my name right, so everybody calls me Sam. And I tell my class if they can pronounce my name correctly and also spell my name correctly, they get an A. If we can do one of the two, they get a B. People who get C's call me Dr. Sam. And people who are getting F's call me by other names. All right, so this is something I want to put it up here. It's an integrated math science professional development program for school teachers. One reason I'm putting this out is to let people know we are doing this. The other one is I'm sure there are people doing similar things, and I like to hear from them. One thing I forgot is to put my email address. It's vsam@mst.edu, but I think everybody got participants' names and emails, and you can look me up. The one with the longest name start with an S. Anyway, I have been doing these workshops, math workshops for school teachers, since 1996. And there's also a physicist called Alan Pringle who used to do physics workshops for school teachers since 1989. And we used to compete against each other for this funding, state funding for these workshops. And one year, about 7 years ago, we decided, more than 7 years ago actually, we decided let's not compete against each other, let's join hands. So since then we have been running integrated math science programs. We also got a biologist involved with us 6 years ago, and that's Dave Westenberg. He's a biologist involved in a lot of K through 12 activities. So this is a summer professional development workshop on inquiry-based learning for school teachers. We have done middle school most of the time. We have also done high school, and we are going to start doing a 3-year program for elementary school teachers starting this summer. The next slide, please. All right, let's go through the whole thing. So it's for middle school teachers, I told you that, emphasis on math science integration, and a 2-week summer session and 6 weeks follow-ups, and then there are classroom visits. Okay, next slide, please. Let's go through the hands-on activities. And these are basically science experiments or simulations. And we gather and interpret the data. That's where the mathematics comes in, obviously. People have to make sense of the science experiments or the simulation experiments, and you have to do a lot of mathematics, starting from fractions to probability to graphing. And so the idea is to blend in both science and math and try to basically leverage one against the other and learn a little bit more and make it inquiry-based activities a little bit easier to perform. Okay, next slide, please. Okay, let's go through the whole set of goals. These are the goals we submitted to the granting agency, but what I want, sorry, no. We're kind of going backwards, that's fine. Yeah, that's the goals. The last goal is what I really wanted to concentrate on, which is to enhance participants' ability to leverage the natural synergy that exists between science and mathematics. And that's what we try to exploit in these workshops and let the teachers do that. Now, the teachers can do integrated math science activities in their classroom. It's easier for elementary school teachers to do that, not so easy for high school teachers. But if we are not going to integrate math science, at least talk to the science teacher and see what she or he is going to do and try to link your activities with those activities so you bring scientific data into your math classroom and use math concepts when you are teaching science. So we are going to have teams of math science teachers coming to these workshops. Next slide, please. So that's our participants 3 years ago. Let's go to the next slide. We'll skip over the next. That's a group of participants, and the one in the yellow shirt is actually our biologist. Okay, next slide, please. This lady out here is a retired teacher. She has come to our workshop. Even though she's retired, she volunteers to work in her schools. She comes almost every year. We don't pay her anything, we don't do anything. She just enjoys coming to the workshop. So we have at least one groupie. Okay, next one, please. That's the electricity experiment. Go ahead. That's class presentations. The one in the white hair on the left-hand side is Alan Pringle. He's our physicist. Let's go ahead. Now, that's a simple experiment we do with elementary school teachers. Blowing bubbles. The science part here is to try to find the formula that makes the biggest bubbles. The math part is the students actually measure the height of the bubble. When the bubble bursts, you have a little circle form, and you measure the diameter, and you measure the circumference with a string. So the students, what they try to find out is there's a relationship between these people. They don't know about pi. These are elementary school kids. They blow bubbles of different sizes and mess with their numbers and see whether they see a pattern. And some students do see a pattern. And for them, pi is actually 3. Okay, it doesn't matter at this level, right? Okay, next slide, please. That's a probability experiment, believe it or not. Now, that costume is actually what people wore during the time of the plague. They wore that big, long mask so that no pollutants. They thought there's something in the air that makes people sick. Whatever that substance won't come to you. So actually they wore something like this, went house to house looking for people with the plague. Now, we do this activity where we have stations. You can see very vaguely some of the cities written on the whiteboard. Boston, basically it's England, Brisbane, and so on and so forth. Medieval cities. Every city is basically a table with a brown paper bag with beans in it. All the cities have red beans, except one city. It has red beans and black beans. And what happens is people go around, pick 2 beans, go from one table to another, that's one city to another, and look at your beans. Once you look at your beans, if you have a black bean, you go to the next city, and then you die there. But you put your beans in the bag. Is my time getting up? All right, so anyway, that's what it is. We'll stop with the plague. And hopefully there'll be a plague of IBL that's going around. And if you are going to do something like this, please let me know. Thank you.
So next is Brian Katz, and then Corey Clarkson, and then just give me 1 more minute of your time before you rush off for snacks.
Hello, everyone. Hi, good, better. So I try to every year give a 5-minute report about the big thing that's bothering me about IBL teaching and what I'm working on right now. And right now that flag relates to Starbird's talk last night. These sort of long-term goals about confidence and the ability to explore and creativity and all these goals. And so I'd like to sort of offer an analogy. Many of us come to IBL because we realize that if the goal was for students to understand conceptually, for example, calculus, rather than us doing the conceptual work and then practicing the computations, they should do the conceptual work. But I think there's an exactly analogous thing that we need to push ourselves on, which is if we really think that what we're teaching our students to do is to ask and explore their own questions, that needs to come to the surface. I do not think that by having them explore in the context of an inquiry-based course, it will necessarily and for all students lead to these outcomes. I think it's much more likely. I think they're developing some of the basic skills along the way. I think we're heading in the right direction. But I think if we really want this other goal, we have to bring the inquiry to the surface. It can't just be inquiry is present. We have to reflect on it. So metacognition and other kinds of things. So if this is an intriguing idea, there are a number of things you could do. But one of them is that Elizabeth Thorin and I are running a contributed paper session at the joint meetings next winter called Teaching Inquiry. And if you look at the description, this is the goal. We want to hear people who talk about how they actually teach their students to inquire, not just how they use inquiry in their classroom. So how they're bringing the inquiry to the surface, how they're helping their students become consciously aware, internalize those things, and make the inquiry process, not just the conceptual work that we do through inquiry, their own.
And Corey Clarkson.
Minor correction, my name is Corinne Clarkson. Fine. Anyway, I'm here to talk about the New York City Teaching Seminar, which is a seminar I started 2 years ago in an effort to increase my familiarity with the math education literature and to build a community of mathematics instructors on Manhattan. So, first of all, if there are people coming from the New York City area, this seminar meets once monthly during the academic year, so about 4 times a semester, to discuss a selection of readings from the math education literature. And these readings for each meeting tend to surround one theme, and then there's about an hour-long discussion. We have a website. The easiest way to find it is to just search the NYC Teaching Seminar. The other reason I'm up here is I'm always looking for more topics, more pieces of literature to discuss. And I know there are many math education literature, math ed researchers here, as well as people who are engaged with math education research. So if you have suggestions, an article that you found inspiring, your own work that you think people should be reading and thinking about, I would be very interested in hearing about that. So I have my email written down here on the document cam, if we can get that up. And if you want to email me, track me down while I'm here, I would love to hear from you. Thank you.
So I want to thank everybody for sharing such good ideas and concisely. That was awesome. Randy Cohn is standing in the back of the room. If there's anybody who still wants to contribute there, I chose not to have my room made up $5 coupon to Randy to have it donated to the local food bank. He's taking them right now. He's going to have that process finished this morning, so you have right at the beginning of our break to get those to Randy. There have been a couple of questions that have come up about other resources. I'm going to try to get those all on one sheet of paper that maybe I can rope Stan into putting up at the beginning of the next thing. We do have about a 25-30-minute break for refreshments that are out in the hallway, and then we'll meet back in this room for another plenary session. Thank you.
Sometime I'm gonna rap like that. Sometime.